Okay. Hello, everyone. So today I'm going to present a live session of exploratory data analysis. How it is done using pandas. So let me start because the time is short. Okay. So let me share my screen. The screen is showing, I hope. Okay. So today we're going to let me delete all this. Okay. So what is exploratory data analysis in Python? Exploratory data analysis means that we, uh, when we analyze some data, the first thing that we want to do is to know about the data set, know about different aspects of it. And after that, we try to extract some informative knowledge, or rather say insights from the dataset, and visualize and represent those knowledge to our client or to the stakeholder. So it's a huge topic. It's a very uh, has very vast implications, vast impact on businesses, organizations, and individuals. And these days, you'll see that these kind of analytics are being sorry, presented to us uh, through app, means mobile apps, desktop apps, websites, uh, different uh, types of smart gadgets through that. So these kind of analytics are everywhere. So without further delay, let us start. Uh, Today we are going to use the TIPS dataset. It's a very uh, well-known dataset uh, in the data science community, and it contains these features: total bill, tip, sex, smoker, day, time, and size. Each row contains the record of a customer visited visited in this restaurant. So it's a restaurant dataset, and every row contains the record of a customer, data about a customer. Uh, how much did that customer paid? How much did that customer tipped? What is the gender of the customer? Whether he or she was smoker or not? What day the customer came? What time the customer came for lunch, dinner, or something like that? And size means how many were with the customer, including the customer. So we're going to analyze this data set. So let us first. So this data set I have downloaded from the Kaggle website. It is very well known, very easily available, and it's quite small, I think. Okay. Let us see. So this is how it looks. Now I'm going to go to Jupyter Notebook and try to answer these analytical questions, these type of questions, and these types of insights that we're going to we will try to uh, discover from the dataset. There are all total 25 questions. I'll try to solve all of them within 1 hour. Let's see what happens. So first thing that we need to do is to import our required libraries. So import numpy, import pandas, import matplotlib. Okay, so those are imported. Now I need to bring the data set into my current environment. Okay, so I'm using Jupyter, and the folder where this notebook is, and that folder contains a subfolder called data, and inside that folder called data we have our dataset, tips dataset. So for that I'm going to do pd dot read csv current folder, under that data, and under that tips dot csv file, and we need to store this reference to a variable, say df, and we're done. So it has been loaded. So let's check for a moment. So yes, it's there. Okay, so let's begin our analysis. So the first question is, how many features are there and what are they? What are the features we have in this data set and what are they? We just copy and paste these. So that's the first question that we would like to answer. Okay, so for that, I'm going to do a simple info, df.info, and we can see that we have total 244 entries, 244 entries, and these are the columns that we have: total bill, tip, sex, smoker, day, time, and size. বাইরে থেকে noise আসছে। So we can see that we have total bill, tip, these two are of type float, 64 means decimal, and we have size, that is integer, in 64. Rest of them are categorical data, means string data, object data. So in standard, it is a standard practice that uh, we should write these answers in normal text form, in normal uh, descriptive format, you may say. But since we are in a rush, I'm not going to do that. I'm just going to show you the answers and how to get them. So that's the technical thing, right? So that's the technical thing that we have done. But the question was not that technical, and the answer will also be in such a manner that everyone can understand, every non-technical person can understand. So from this, we can write those answers. I'm not going to do that here, but that's how it should be done. I'm just going to show you how to get the answers. Okay. So let's move on to the next one. Show basic statistics of the features, both numerical and categorical. Okay. So for that, I'm going to use two cells. So the first cell, in the first cell, I'm going to say df dot describe include object, meaning that I just want to see the statistical features or statistics of the features of the categorical variables. So there you go. We have sex, smoker, day and time, 4 columns, and we have counts of all those columns, how many values are there, how many unique values are there. So for sex we have 2 unique values, smoker we have 2 unique values, Day we have 4 unique values and so on. And what are the values uh, that has highest frequency, highest number of repetitions? And that is for sex we have male with 157 repetitions. For smoker we have non-smokers that top the list, and we have 151 non-smoking customers. Uh, the most customers came on Saturday, uh, 87, and so on. So that is statistical features of a basic statistical feature of the categorical data. Next, we are going to find out some basic statistical features of numeric variables. I'm just going to say exclude object, so that it's going to contain all the number type, float, int, everything. And what we have here, total bill, tip, and size. So again, for numerical data, we have total bill first. Its mean value is 19.78, so around $20. So on an average, customers pay $20. Uh, Minimum amount paid $3, maximum amount paid $50. So there is another thing that we can see from here is that the minimum value is way less than the 25th percentile. Okay, and same goes for the maximum value. We have 75th percentile value 24.1, and the max value is way more than that, 50.8. What about tip? In case of tip, we have average tip amount 1.38, $1.4. Minimum amount is $1, maximum is $10. So there is also a very high discrepancy between the minimum value, maximum value, and the quantile values. I'm not going to go into the size because it's not very interesting to me. And the total bill and tip, see what we can say about those things. The first thing we can say that there are outliers. Okay, so there are outliers, means there are people who have paid uh, much lesser than most of the people, and some customers are there who have paid much higher than most other customers. Same goes for the tip also. There is another thing that we should notice is that the mean value is 19.8, almost $20. 50% percentile is 17.8. So that is 50% of the customers have paid less than 17.79, $17.8. But the mean is little bit higher side. It means that we have a slight skewness on the higher side in the distribution of total bill value. And same goes for uh, tip also. So for tip we have $3, and the 50 percentile is 2.9. Okay, not that much, but we have a little skew in case of tip, distribution of tip, but more skewer in case of total bill. And it's because we have some big uh, payer, big spender among our customers. So those are the things that we should write down in our report. But again, I'm not going to do that here. I'm just going to show you how to get the results. So what are the days? And we are going to show it using bar charts. So what are the days the data have been recorded for this particular restaurant? And for that, we're going to do df day dot value counts, and it's going to give me that count along with the unique values for that particular column. So we have Saturday, Sunday, weekends, and Thursday, Friday, weekdays, and individual value counts, means number of customers that came on that day. Now we want to show this using some bar chart. So for that, I'm just going to store this data. So let's say uh, day dy equals to this thing, and then I'm going to plot it. So plt dot figure, plt dot bar. So I'm going to show this using a bar chart. Plt dot bar. Let me do this thing instead. It's going to be easier. dy dot plot kind equals to bar, then plt dot show. So we have our data shown like this. Let me just decrease the fixed size a little bit. Fixed size. Let me make it a little bit wider and less taller. Okay, so there you go. We have our day counts. We have our days, and along with that, we have our counts of customer for each of those days. Now, from here, we can see that Sunday and Saturday tops the chart, and on weekends, this restaurant experience more rush than on weekdays. So it may be that it is in a shopping mall or something like that. We don't know. We don't have that information. But what we can say to the customer, okay, plt.title, weekends are busy. Do something for the weekdays. Okay, so we can say the customer and that you already have uh, enough customer for weekends, but not that much on weekdays. So do something, do some promotion, do some happy hours or something like that, so that footfalls of customers increase on weekdays also. So that's the insight. That's the insight that we can write. Okay, so next one. What are the times? So again, the code should be very similar to this one. So instead of day, we're going to use counts. So let's see. Ty equals to df dot time dot value counts, and after that we're going to say plt dot figure. We're going to use the same fixed size. So fixed size equals to say 5/2. Then we're going to say ty dot plot kind equals to bar plt dot show. Okay, so from here we can see that we have dinner, number of customers that came for dinner, we have number of customers came for lunch, and we can see that there is huge discrepancy between them. So the people who came for dinner, the number of people who came for dinner easily outweighs the number of people who came for lunch. So again, the restaurant is getting enough customers for dinner time, but for lunch time it should do something, maybe promotion, happy hour, things like that. Okay, so let me just write that down. So plt dot title. plt dot title. Few customers at lunchtime change the menu. So jokes apart, so these are the kind of things we are going to say to our client. These are the these are known as insights. That okay, you have very little footfall on during lunchtime, so perhaps you should do something about that. It may help your business. Okay, so next up, what are the sexes? So we want to know about the gender distribution among the customers, and we're going to do it. We're going to visualize this using a pie chart. So again, the approach will be the same. Only the uh, types of plot that we're going to use is going to differ. So again, let's say GND equals to df sex dot value counts. All right, and then we're going to say plt dot figure. So it's going to create a new figure for us. Fixed size. Let's keep it a bit smaller, 3" by 3". Okay. Then I'm going to say plt dot py. Plt dot py, and we're going to supply our values. So gnd, that variable gnd dot values. So whatever we have. So let me show you what we have over there. So let's print gnd once. So we have a pandas series object like that. So we have a series object that has indices male and female, and we have values 157 and 87 respectively. Okay, so let's proceed. So we're going to show that plt.figure and plt.py. For values, we're going to send the values, means 157 and 87. And for labeling, we're going to use the indices. So gnd.index. Okay, and plt.show. Okay, so we have our male and female distribution. Again, males are way uh, uh, larger than, in case of count of males are way larger than female counts. So let me just show the percentage also. With the 0 decimal point, I don't want it. I don't want to show the decimal values. I just want the approximate uh, whole value. Okay, so 64% and 56%. So again, we can write that this restaurant should do something about its female customers. Maybe change the theme of the restaurant. Maybe research a little bit what the female customers want more, and so on and so forth. So that both genders come equally, and that should be their priority. So let's move on to the next question. What are the smokers? Means we want to know the distribution of smokers. How many smokers we have as customers, how many non-smokers we have uh, of customers, and so on. So the approach, again, the approach will be the same. So once we know something, how to compute something, although the questions are different, your approach will almost be the same. So let's say SMK equals to df dot df smoker dot value counts SMK. Okay, let's print the value once more. So we have 151 non-smokers and 93 smokers. Uh, so again, non-smokers are coming more often, and we should not promote any kind of smoking things, I know. So I don't think that uh, here we should say something, but okay, business is business, right? So we can say that, okay, do something about the smokers. Okay. And I'm not saying encourage them to smoke, but do something about it. PLT dot figure, say fixed size again. Fixed size equals to 3" by 3", and then sorry, PLT dot pi. And so we're going to use a donut chart. We're going to use a donut chart. PLT dot pi. And again, SMK dot values labels equals to SMK dot index, and we have autopicity, hello percent 0.0f double this, and then wage props equals to width, and let's say width is not much, say 20%. Okay, then PLT dot show, and we have our donut chart. So we have non-smokers 62% and 38% are smoker. We have our donut chart. I'm not decorating these figures. I'm not. I have shown how to put insight in in the visualization. I'm not going to do that for every question that I answer over here. But if you are doing it, you should do it. Okay, you should always do it. So the next question that we're going to answer is, what is the minimum, maximum, average values of total bills? Are there any outliers or not? Okay, so Now we want to know the total bills, minimum, maximum, and average values, and whether there are any outliers. Okay. So for that, what we are going to do, the first thing is very easy. The min value, max value, and average value. So we can do it like this: df total underscore bill dot describe. So we have our mean, standard deviation, minimum, and so on so forth, and min value and max value. So we have this series object, and from there I can choose several indices. We just so we want minimum value, maximum value, and average value. Okay, so there you go. You have minimum 3.07, maximum 50.8, and min means average 19.78. So those are the uh, minimum, average, and maximum value of total bills. Now, what about outliers? So for outliers, first we need to, I'm going to visualize this total bill column so that we can visually see whether there are any outliers or not. So for that, I'm going to do this df dot total bill dot plot kind goes to box. Okay, before that, plt dot figure fixed size goes to say, so it's going to be a taller one. So let's say it's going to be 4 by 2. Oh no, 2 by 4, like that, and then plt dot show. So there you go. So okay, there's another thing. Show means equals to true. So we have our distribution for the total bill. So this is the this thing, this whisker. So this is the box and whisker plot. This whisker is the 25th percentile. This is the minimum. This is the 25th percentile. This is the 50th percentile. This is the 75th percentile. This is the max value. This is, and we have our outliers. So outside 75th percentile, we have our outliers. Okay, in value and max value. So there are quite a bit of outliers for this total bill value. And now we're going to find, are there any outliers? So okay, so the question is not whether what are the outliers, what are the rows that are indicating outliers. Instead, are there? Okay, yes, obviously we have outliers. We have values that goes beyond, uh, quite a bit of values that goes beyond our 75 percentile value, and those are the outliers that we have. The next question, uh, what is the mean, max, average value of tips, and are there any outliers? So mostly same question, same question. So only the column name is different. So I'm just going to do a quick copy and paste like that. And instead of total bill, I have tip. Okay. So there also we can see that uh, this is a min value, this is max value, this is a 75% value, and we have a few customers who have paid outside the main distribution, outside the main distribution. And The thing that I was talking about, that this distribution is little bit skew. This is the median. This is the median, 50%, and this is the mean. This little triangle, green triangle. So that's the mean. So the mean is not aligned with median, and it has some skewness in the distribution. Here it is aligned, not that much, but we can say that it has aligned. So it is more or less not skewed, but we have quite a bit of outliers here also. Okay, so let's move on to the next question. Show the customer with max total bill. What are other features of that customer? Okay, so here we want to know. Here we want to know about the customer who has paid maximum bill in this restaurant. Okay, and for that, uh, what we should do, we should first say TF and dot sort. Now, if I say sort, we can do sorting in two different ways. We can either sort index or we can sort values. So I'm going to sort values. I'm going to sort values by the column total bill. Okay. Now, if I do that, it's going to give me back a data frame that contains total bill sorted from low to high. And we have our highest paid customer 50.81 at the very bottom. Okay, so I don't want that. I want the customer to be on top. Okay, so for that I'm just going to say ascending equals to false. So it's going to sort in descending order. Okay, so now I have our customer, top paid customer, top of the data frame. So from here, I'm just going to extract the first row. So head 1, and I'm just going to say top bill. Okay, so that is, and I'm going to just print it out, top underscore bill. Okay, so we can see that the top amount paid by customer is 50.81. He was a male, the customer was a male, gave a tip of $10. He was a smoker, came on Saturday at dinner time with 2 other friends. So that's the thing, that's the insight that we have from this answer. Next one, let's move on to next one. Show the customer with max tip. What are other features of the customer? So again, this is a question in the same line, same manner. It's just that only the column needs to be changed. So I'm just going to do a quick copy and paste. So top, instead of top bill, I'm looking for top tip. Instead of total bill, I'm going to say tip. And I'm just going to print this value. So that is the same customer who had paid the maximum bill in this restaurant. So the two guys are the same. Okay. Male, smoker, came on Saturday at dinner time with 2 other people, paid a total bill of $50.81 and gave a tip of $10. So let's move on to the next question. What gender has higher footfalls on weekdays? So we want to know on weekdays who came often, male or female. Okay, so let's deal with this question. So what gender has higher footfalls on weekdays? So first we're going to select uh, all the weekdays rows from the data set. So from the data frame, in the data frame we have rows of data, and some of those rows are correspond to weekends, some of those rows correspond to weekdays. First we're going to select the day part, that is weekdays, and we have Thursday, THUR, and Friday, FRI. So is in take two positional argument, one given. Let me just check it out. Is in so values Thursday, Thursday, and Friday. Okay, so now we have either true or false for every row. And now we're going to use this as a conditional index to our data frame. Okay, so now we have a data frame that has its day value either Thursday or Friday. Now from there, I'm going to count all the male and all the females. Okay, so from here, I'm just going to say choose the gender sex, the column sex, choose sex, and then do a value count. Spelling mistake is there. Okay, so surprisingly, we have equal distribution of gender among customers on weekdays. So we have 41 females and 40 males that came on weekdays. Okay, so on weekdays, female came more often than on weekends. On weekends, um, males are more, the most frequent customer in this restaurant. Okay, so it's quite a bit. It's a little bit complicated. We can simplify it uh, a little bit, but my point is not to give a tutorial on pandas, but just to show how we can uh, extract insights from a data set. So what gender has higher footfall on weekdays? You can see that it is female, and from value counts, I can just do this thing, IDX max, and you have your answer, female. Okay. So let's move on to the next question. What gender has higher footfalls on weekends? So we just need to change the day name. So this query is good. Just need to change the name of the days from Thursday to Saturday. Male. So let me just remove this one. See the counts. Okay, male came 117 on weekends, female only 46. So obviously it is going to be male. So the restaurant should do something. So on weekends, so that more female customers come on weekends in the restaurant to the restaurant. Let's move on to the next question. List top 10 tippers. Okay. So the client wants to know the top 10 tippers. So we're going to do a sorting based on the tip. So first choose tip, then say sort, values. We have this. Okay, sort values, we have this. But we don't want the tip only, right? So we are not going to do this selection. So df dot sort values, and we're going to sort by the column name tip, and that's okay. And we're going to have a data frame like that. Again, top 10. So let's say ascending equals to false. Right. So we have our top customers on the top of the data frame, resulting data frame. And from there, I'm just going to say dot head 10. So there you go. You have 10 customers listed like that. Okay, so 50.81, 40.33, 39.42. And obviously, we want to know more about uh, the customers other than the tip amount. So $10, $9, $7, $6, and so on and so forth. Along with that, we would also like to know uh, about other things, the gender, smoker, day, when they came, and so on. So list top 10 tippers. That's the question. That's the answer. And from where here we can see that obviously males are top 10 among the top 10. There are 9 males and only 1 female. Okay, so let's move on to the next question. List top 5 tippers on weekends. Okay, so we want to know who are the top tippers on weekends. Okay, so let's deal with this query. So I'm going to say df. So I'm just going to take the data frame for take the subset of data frame from our current data frame for weekends only. So df dot day dot is in, we create a list. It's going to be Saturday and Sunday. And we're going to use that as an index, conditional index to our data frame. So we have data only about weekends. Now I'm going to sort this data frame by the tip column. So the thing that I was saying that, okay, what you can do, you can put this inside a variable and say d1 dot sort values, like that, sort values by tip ascending equals to false, and from that we're going to select top 5. So that's the answer. Our top 5 customers who have given according to tip amount on weekends. So we can see that there are 4 males, 1 female, and all of them came on Saturday. Two of them were smoker, three of them were non-smoker. All of them came for dinner with more or less same uh, size of accompanies, same size, same party size, three or four, like that. Next up, who are who is the generous tipper, a smoker or non-smoker? So again, very interesting question. Uh, so we would like to uh, figure out um, whether a smoker is a generous customer usually or a non-smoker. So for that, we're going to create a group. So df.group by, and we're going to group by the column. Let's see, yes, group by the column, smoker. So it's just going to divide the whole data set. I'm just going to say axis equals to 0. So it's going to divide the whole data set row wise and smoker on the value of smoker. So yes or no, like that. And then we're going to say group by this thing, axis equals to 0. And then we're going to do what? We're going to do, we're going to apply some aggregate function. So for this, say mean, and there you go. You have for smoker, okay, generous tipper. So from that, choose the tip column and then do the mean. So on an average, uh, the smokers have given more tip than non-smokers. Very little, but there is a difference. So according to this, smokers are generous tipper. Now the thing is that this generous thing, it's a little bit misleading because uh, we can use the average value like this, but we can also use the sum, meaning that here it means that on an average, a smoker has given $3 tip and a non-smoker has given $2.99 tip. But if I take the sum, then you'll see that since non-smokers are coming more often in this restaurant, the total tip amount, so this tip amount is extra income for the restaurant, right? This total tip amount is way greater than the total tip amount given by the smokers. So you have to decide how you are going to uh, present this data. Usually, you should present this data as it is. You should not hide anything. You should not be biased. You should not say, okay, since the mean showing me this, I'm going to say uh, a smoker is a generous one. Or, okay, since non-smokers are given more uh, total amount, total tip, so they are the generous one. We're just going to say this is the thing, this is the scenario, and if we look at the smoker or non-smoker chart, then the smokers on an average gives a little bit higher than non-smoker, but overall non-smoker contribute more to the tip amount uh, than non-smokers, as than smokers. I'm sorry. Okay, so let's move on to the next question. Probably the last question that I'm going to solve today, because I do not have time. Okay, so who is the generous tipper, male or female? Again, the same thing. We are going to do a group by, but instead of smoker, we are going to use the gender column, the sex column. Okay. So from here we can see that on an average, males are generous than females. But again, let us check of some value. Instead of min, I'm going to use sum. And here you can see that, okay, so since more males are coming onto the in the restaurant, uh, total tip amount is also higher for that gender. But are they generous? Okay, we don't know. We don't know that much because these amounts are again uh, quite uh, neck and neck. These values are biased because females are coming less often. Okay, females are coming less often. So if the restaurant figure out some way of attracting more female customers to their place, then that scenario might change. Okay, list top 5 female tippers. How many of them were smokers? Okay, so let's see. List of 5 female tippers. How many were smokers? So first we're going to uh, extract all the female customers from our data set. So df sex equals to female, and we're going to use this condition like that. So we have all our female customers, and then we're going to sort the data frame by the tip amount, tip ascending equals to false. So we have our top female tippers on the top. From that, say head 5, and we have our top 5 female tippers. Okay, top 5 female customers. Now that's the answer of one question. Another question is that, okay, let me first store this information in a variable, so t1. So t1 is this. So that's the answer to my first question. Second question, how many of them were smokers? So we're going to do a count on this. So t1 smoker dot value counts. Okay, so only one of them were smoker and 4 of them were non-smokers. Okay, so it's almost 1 hour now, and I think I have given all of you an understanding, a basic understanding of how exploratory data analysis are done using pandas and Python programming language. Hope to see you soon. That's it for today. Thank you.